Good everyone, my name is Graphics. In this video, we want to solve a problem involving development and true shape of an hexagonal cylinder. And the question goes like this. It says, a right regular hexagonal prism of base edge 20 mm and height 50 mm rests on its base edges perpendicular to the VP, that is vertical plane. A section plane inclined 45 degrees to HP cuts its axis at its middle. Draw the complete development of the truncated prism, including the section surface. Now, the key word here is that what? The edges of the hexagon is what? Is perpendicular to the VP, to the what? Vertical plane, right? So one thing you need to know, we'll talk about hexagonal prism. It means that what? The base is what? Is hexagonal, right? So what I'm going to do is I'll take my instrument and I'm going to draw my horizontal line this way from this point. You can see that. And I'm going to draw my vertical line this way from this point. You can see they are meeting at this point. Now, since we are told that the edge of the hexagon is 20 mm, right? So we are going to measure, that means our radius is what? 20 mm. So we'll measure 20 mm on our meter rule, 0 to 20, and you place it here. And you're going to draw a circle faint line. You can see that. Now the next thing you do is with the same radius, place it at this point, slash an arc on the circumference towards the left and the right this way. You come here also, you place it here to the right and also to the left. You can see that. Now you are going to take your meter rule and you join those edges together. So if I join this together with this, from here to here, and from here to here, and from here to here, and here to here, and this side also, and this side also. You can see that. Now the next thing is I'm going to mark here to be 1, here to be 2, here to be 3, 4, 5, and 6, and I'll project it vertically upward this way. You can see that. Now this will be representing the plan, and I'm going to cut here. I'll close here up this way. You can see that, and we're told that the height is 50 mm, and that will be with the elevation, which is what we have here. So the height is 50 mm, and I'm going to measure 50 from this point, 0 to what? To 50 here. And I'll close it up using my faint line. Is that taken? Now this is what we have here, right? Now if here is 3 and 4, this point will be what? 3 comma 4 because they're on the same plane. Here also will be what? 3 comma 4. If here is 1 comma 6, here will be what? 1 comma 6, and here also will be what? 1 comma 6. Is that taken? And if here is 2, this point here will be what? 2 comma 3, 2 comma 5, right? Or here will be what? 2 comma 5, depending on what you want to do. Now after we've done that, we're not told that a cutting plane cuts this hexagonal cylinder at an angle of what? 45 degree through the center, right? Now half of 50 is 25. Half of 50 is what? 25. So if I measure 25 from here to here, this is what? 25. Then I'll take my 45 degrees set square, right? And I'll place it here. And I'll place it here. So this is at an angle of 45 degree when you place it this way. And if I move it to the center, half of this cylinder, which is what? 25. And I'll now draw a section plane. This. You can see that. So this is what I will now thicken, because that is what we are actually told to do. So I'll now thicken this. So when you section it, this is what you will be what? Having. Right? So this is the section plane. We're looking at this direction. This is our VT here. This is T and this is what? V. You can see that? Now, first thing we need to do is when you cut this off, what will you see? That is what it is actually telling us. So we want to first of all draw the true shape. And the true shape, what will be the true shape? When you section this part, right? So when you section this part, means that all these parts here will be what? Will be sectioned. So I'm going to close all here up this way because you've applied a cutting plane. This is what you're going to be having. So this is what we're having. So when you cut it, this is how the surface will look like from the plan. But this is not the true shape. So how would the true shape look like? I told you earlier, when you project with 45 degree, you draw another 45 degree that will be perpendicular to this. But before then, you take your 45 degrees set square, and all those points that the cutting plane touches the cylinder, I'll project them out. I'll project them what? Out this way. Let me bring it down. Don't forget it's resting on your what? Your T square. So I'm going to what? Project them down this way. So this will come. This will also come. This will also come. Right? And the aim of an objective of doing that is that so that this line you're drawing must be perpendicular to the cutting plane. So if I project with 30, if my cutting plane is at 30 degree, my line will be at 60 degree. If my cutting plane is at 60 degree, my line will be at what? 30 degree. If it's at 45, here will be what? 45. So that the summation of both of them will be what? 90. Now the next thing I'm going to do here is to draw a plane this way, like a line this way. Right? This line you're seeing Are you with me? The line you're seeing, the thickness of this line is, so this line you're seeing here, right, can be along the x-axis you're seeing here. Is that taken? So if I take my compass, if I place it at the center line here, you can see that. Don't forget that this is also like this before we come back. So I'll take this is an hexagon and it's like this, so here is close to. You see that? So we'll move forward. Now if I place my compass at 1 to 2, you can see that. Don't forget 1 to 2 and this center point to 2 and here to 5 is the same thing, right? So what I'll simply do here is I'll trace it to the line of 2, which is this. I'll come to the center point here. I'm going to mark to the right and also to the left. You can see that. Similarly, I'll come to the 3 here, place that 3, right? I'll trace it to the line of 3, which is this. I'll come here. I'm going to mark to the left and also what to the right. You can see that. Then I'll come to this line here, center point here, put it at 1. I'll trace to the line of 1 here. I'm going to mark to the left. Let's mark it this way. I'm going to mark from here to the left and also what to the right. You can see that. So if I'm to do the needful, this line here you see here, let me start from here. This is 1, so here will be 1, right? And here will be what 6. The next one will be what 2. That's the line of 2. And the following will be what 5. Then the next one will be what line of 3 here, 3 at this point, and what and 4 here. So I'll use my meter rule and I will close it up. So because 3 and 4 is connected, so I'll connect 3 and 4 here, right? 1 and 6 is connected. I'm going to connect 1 and 6. 2 and 1 is connected, so I'm going to connect 2 and 1, right? I'll connect 2 and 1 this way. 3 and 2 is connected. I'm going to connect 3 and 2 this way. Connect 3 and 2 this way, right? Then 4 and 5 is connected. You can see 4 and 5. I'm going to connect 4 and 5 this way. Then 6 and 5 is connected. I'll connect 6 and 5. So this is the true shape of this hexagonal prism. Yes, the previous video we did the true shape of of a circular of a cylinder, right? We did of a cylinder. So if you want to access that particular video, you can click on this link here in order to watch the video on the true shape of a circular cylinder, right? So this is what we have here, right? We'll call that we'll call this the true shape or the section part if you want to. Now we're done with this. Now the next thing is for you to draw the development of this shape. When you cut this figure out and you stretch it out, right? You stretch it out. We'll see the word called the lateral surface. You stretch it out to get the lateral surface. So that's what we call the development, right? Or the pattern. So what I'm going to do is I'm going to project this outward this way, and I'll project this also outward this way where it cuts it out. You can see that. And I will take this. So I'm going to take my instrument and I'll place it here. at any given distance, as long as it's not affecting the other diagram. And I can just choose here and say, okay, draw my vertical line this way. That'll be my reference point. I'll call it my point 1. Now, with the distance of any of these two, either this and this, or this and this, don't forget they're all the same, or this and this, any of them, right? I'll come to here, I'll start marking. This is 1, the next one will be what? 2. This is point 2. The next one will be what? 3. This is point 3. The next one will be what? 4. This is point 4. The next one will be what? 5. This is point 5. The next one will be what? 6. This is point 6. Then back to 1. This is what? Point 1. Right? That is what you start from 1, you end at 1. Then I'm going to project all those points upward this way. Just like you can see here. Project all those points upward this way. You can see that is what we have here. Now the next thing is all these points they are the section plane cut through. I am going to project them. So I'll project this point this way. You can see that. I'll project this point to this way. First of all, I project the point of 1, right? You can look at the line of 1,6 here. If I project it, 1, this is 1 is going. Where 1 meets 1 is at this point. So this is my point 1 again, right? The next one is what? 2. If I trace the line of 2, this is the line of 2. I will move here, project this way too. So this is the line of 2, where 2 meets 2 is here. You can see that. I'll come to 3, follow the line of 3, where 3 meets 3 is here. Right, this is point of 3. This is 2. Then I'll come again. The line of 4 is on the same line as 3. I'll move again. This is the line of 4 here, where they intersect. Then that of 5 and 2 on the same line here. This is the line of 5 here at this point. Then 6 and 1 on the same point here. This is the line of 6 at this point, right? Then this is line of 6 here. Then back to 1 and the same line again. If we trace 1 on the same line, this is the line of 1 here. Is that taken? Then I'll take my meter rule and I'm going to join this point together. The first one I'll join from the base here, everything from this point to this point, right? And I'll join from here to here, and I'll join from here to here, right? And I'll join from here also to here. Then I'll join from here to here, from here to here, from here to here, back to here too, right? Then I'll close here up this way. You can see that. Now the next thing you do is to draw the surface here, what we call it, the bottom surface, right? That is the bottom surface. It can be either between 1 and 2. It can be anywhere. It can be between 1 and 2, 2 and 3, 3 and 4. But I will put mine in what? 1 and 2. So in doing that, I'll just place my compass here, these two radius here. I'll strike an arc this way, right? So where they meet in this manner, where they meet here, I will draw what? A circle this way. Right, so with that circle, I'll place my compass here, I'll strike an arc. I'll place it here, so I'll strike another arc this way. I'll come here, I'll strike an arc. I'll come here also, I'll strike another arc. You can see that. So where they meet, I'm going to start joining them. So I'll join this to this. I'll join this to this. And 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 I'll close here up. I see that. So this is what we call the bottom surface, right? This is the lateral surface. This is the true shape, right? That is the section part. And this is how the plan will look like, right? So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.